We'll go ahead and get started on 6.4 here. So as I said at the end of 6.3, we do have some cases where the disk or washer method can't quite give us the solid we want. So suppose we have, say, like a semicircle, from A to B, and we want to take the region maybe inside the semicircle, say that, and we want to revolve it about the y-axis. Right? So if we do something like that, then we run into an issue, right? What I've just drawn here is only part of the story. We have this as well, and in fact, we've got the idea that we've got this washer that can't really be drawn in a way that helps us avoid involving the same function twice, right? So if we go ahead and draw the washer here, we've got part of the function creates the outer radius, but part of it creates the inner. And in some cases, we can kind of split this into two different functions. But as you can see, there's no way to really make this cleanly happen using the disk or washer method. So we're going to have to take a different route here. And so the route we'll use is going to be called the shell method. So we'll go ahead and look at cylindrical shells instead. So we're going to start with a region. And we'll start out first off with the region being sort of the more typical case, or the idealized case that is, where our region is actually touching the x-axis. So we'll start with that, and we'll kind of develop from there. So if we do that, again, we want to kind of get this solid, but we can't use the disk method because it's going to end up touching itself here. So what we're going to do instead is we're going to keep things in terms of x. So even though we are rotating about the y-axis, we're going to say, how can we keep things in terms of x? What happens if we take a strip of x and we say revolve that about the x-axis, or about the y-axis, that is. So if we do that, we're going to end up with another strip over here, and that strip is going to create the outside of a cylinder. And so what we'll do is we'll look at the surface area of the cylinder on that front face there, and as it wraps all the way around. And we'll do the same thing for different strips of x. So we're also going to do that for, say, this guy out here. And so we'll end up with another cylinder over here. And we'll kind of move the x's around. So we'll go ahead and look at those surface areas, and we'll add those together, and that'll be our slice and sum strategy. All right, so let's go ahead and take a gander at some pictures here. So we're taking some function, and we are going to revolve it about sort of an axis that maybe you wouldn't expect, right? We've got our x values here that are determining a and b, but we're still revolving about the y-axis. So when we revolve it, right, by its nature, we'll have a hole in it, and we end up with something like this. Right, so what we want to do is we want to grab a chunk of this, and then we'll revolve it. And when we do that, we end up with a cylinder with a big hollow in the middle. And we'll kind of move the x's around so we grab cylinders in every single part of the function. And as you can see, we're going to have a thickness of the cylinder, but that thickness is delta x. It's going to go down to dx. Right, so then we'll take a look at this last one here for this particular section. So think about, how do we find then the volume of this cylinder and add those volumes together? Well, we're going to use the surface area, and we're going to use the thickness. All right, so we think, what is the surface area of this cylinder? Well, you do that by finding the circumference of the cylinder, and you multiply that circumference by the height. So when you do the circumference times the height, it'll give you this blue surface area here. We'll multiply it by the thickness, and that'll give us the volume of this cylindrical chunk. Right, so in general, we're going to have a piece that looks like this. Right, we're going to have some sort of radius, r. And so we're going to look at the circumference around the circle here, which is going to be c equals 2 pi r. And so this surface area, we'll call it, of this face that goes all the way around the cylinder, the surface area will be 2 pi r times the height h. And finally, the volume will be 2 pi rh times the thickness. And so we'll go ahead and start turning this into x stuff. We'll call the thickness delta x. So the thickness of this cylindrical bit here, delta x. So we're going to take this back now. We have to get everything in terms of x back up here to actually use it for a function. Right, so we're going to have to translate r and h. Right, so if we take a look at, say, the cylinder that's already drawn here, right, we have a particular x value. The x value that determines where our slice is happening. That is the radius. It goes from the middle all the way out to the radius there. So we're looking at our volume here is going to be 2 pi, we'll have x. Then our h is going to be the height of our function. F of x delta x. And we'll go ahead and we'll add up all those cylinders. But we know that that means we're going to end up integrating, turning this guy into dx. So that's our shell method. So we'll have continuous functions here, and we'll go ahead and look at the shell method in general as well. So if we have, say, two different functions, like that, and we want to revolve about this other axis here. Right, the only thing that changes from this example to back what we saw before is the height of our cylinder. Right, the height of the cylinder, instead of just being f of x, is going to be f of x minus g of x, where f of x is the top function and g of x is the bottom. So we're going to have, again, from a to b, 2 pi times the radius, which is just x, times the height, top function minus bottom function, times our delta x, right, which turns into dx. So it's just a slight change. We're really kind of turning things sideways so that we can take these functions that would normally be very difficult to revolve around some different axis, right? This is very plainly a washer method if we were to do it this way along the, about the x-axis, right? But it's a lot harder to think of it around the y-axis, and that's how we turn to the shell method, or rather y. All right, so let's take an example of two functions at once as well. All right, we see that as we revolve, we're again making a cylinder, only this one is not touching the x-axis. So our height of our cylinder is the only thing that really is going to be affected in our integral. Right. So it's an analogous formula for the shell we're going to also have, there we go. We're going to also have methods for revolving about the x-axis when we reverse the roles of x and y. So the shell method, right, is going to be backwards. If we're revolving about the y-axis, we're using x's. If we're revolving about the x-axis, we're using y's. So here's our first kind of wrench in our what we typically would think of, right? The disk and washer method matches up. If it's the x-axis, we're using x. If it's the y-axis, we're using y. If it's the shell method, it's backwards. So let R be the region bounded by the graph of f of x equals sine of x squared, the x-axis, and the line x equals root pi over 2. Find the volume of the solid generated when R is revolved about the y-axis. So we can kind of just see it in this picture here. Unless it skips me around like that. That we are revolving this about the y-axis. We're going to take this guy and revolve it about the y-axis. This would be very difficult to do if we keep things, sorry, if we wanted to change things in terms of y, right? Look at this formula. It's going to be an inverse sine and a square root, and it's going to be a mess, right? And it's also, if we were to change things in terms of y, our region would kind of be going the wrong way. We'd be looking at this region down here instead of the region on the other side. So definitely two aspects that are kind of forcing us to keep things in terms of x here. So what we're going to have to do then is set up a shell method problem. All right, so if we kind of just look at what's going on here, I'm just going to kind of bulk it up a little bit. So we're looking at 0 root pi over 2. And we're going to grab just a section here. Make a cylinder. So we're looking for the surface area here. So we're integrating from 0 to root pi over 2. Right, and again, we go back up. Circumference is going to be 2 pi r. So our r turns into x. So 2 pi x times the height of our cylinder, which is just the function value. Another nice thing about the shell method is notice that we are not squaring. Since we just need the height, we don't need to square it. We don't have to put a square on this sign. That would make things very difficult. So that's another thing that would kind of direct us when we're talking about, do we want to use washer method? Do we want to use shell method? Is think about which would kind of make the integration easier, right? Squaring sign makes things harder. So if we can avoid it, we want to. Another thing we see here is that we have an x on the outside and x squared on the inside. This makes it possible to use u substitution because we have the derivative of this guy right here, 2x. So another thing that the shell method gives us is another x to play with on the outside of our function. So we'll go ahead and move the pi outside and leave that 2x on the inside, because I'm going to use u substitution. So we'll let u equal x squared. So du is 2x dx. That should be an equal sign. It kind of bled a little bit. 2x dx. So integral from x equals 0 to root pi over 2. And we're looking at sine of u, du. So when we integrate, we take the antiderivative here, cosine of u. We know the derivative of cosine is negative, so we should have an opposite on that. Right, so we've got negative pi, and we will evaluate cosine of u, and we'll go ahead and replace the u with x squared at this point, from 0 to root pi over 2. Right, so we've got negative pi, and then on the inside we've got cosine of pi over 2 minus cosine of 0. So notice that I have a negative pi out front. Your answers for volumes and areas should always be positive. So if you end up with a negative, you know that something's gone wrong. So we're hoping here that we end up with a negative inside the parentheses. We got negative pi. Cosine of pi halves is 0. Cosine of 0 is 1. So we get negative pi times negative 1, and we got it. We got pi. Pi cubic units. Just pi would be okay. Again, if you end up with a negative, it means something's gone wrong. Right? So that's an example of the shell method. As you can see, it kind of, the problem will be written for shell method, so having that x there would be very nice. Right? Let R be the region just in the first quadrant. Remember, that gives us a couple of constraints here. The constraints being that we have the lines x equals 0 and y equals 0 are going to be borders for our region. So you can see that here, the vertical and the horizontal line there. Bounded by the graph of y equals root x minus 2. So you can see a square root graph, and it's been shifted to the right too. So I'll go ahead and just draw this bigger as well. So it should intersect right here. And we're looking at first quadrant exclusively. So let's leave that there. And the line y equals 2. So let's pretend that we can't see where that's supposed to cross. So we'll go ahead and find the intersection. Right, just so I know that I've drawn this correctly here, right? Square both sides, 4 equals x minus 2, so x equals 6. That means that this should intersect at 6. So there we go. So this is our region. We're revolving it about the x-axis. And then we're also going to find the solid generated when r is revolved about the line y equals negative 2. So we'll start with first, find that volume. We'll call it part A. We'll call this part B. All right. So if we take just a quick look at what our region should look like, or sorry, what our solid should look like, we'll see, that we are able to, if we wish, use the disk method here, and then right about here, all of a sudden we change to the washer method. So if you really wanted to, you could kind of force disk washer method, but you'd have to use both. And so that's one of the big problems with the disk washer method in this particular case. You can see that there's kind of a switch where we have top function is our line, bottom function is just the axis. Here, top function is the line, bottom function is the square root. So that's why we'll go with the shell method, because here the shell method will be more consistent. We'll always have top is the parabola in this case, and the bottom will just be our y-axis. All right, so for part A here, we are going to want to use the shell method for consistency's sake. That being said, if you do use the disk washer method and you kind of mix them together, you should get the same answer if you do this correctly. All right, but as it sits, we'll go ahead and do the shell method. If we are doing things about the x-axis, you can see that my slices are in the horizontal direction, which means we are going to be using y, right? This is what should be moving up and down. Since it's moving up and down, we're keeping things in terms of y. Right, so we're starting at y equals 0, and we're going to move all the way out to y equals 2. So our first slice is going to be right here. Last slice is going to be up here. Going from 0 to 2. 2 pi y, and then the height of our cylinder will just be the function. We have to keep things in terms of y, though, so we're actually going to have to square both sides and then add 2 to both sides. And so this is going to be the guy that we put as our function. All right, so we'll go ahead and take the 2 and the pi out. Then we'll multiply, distribute rather. So y cubed plus 2y in there. We'll use the power rule. So increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. We're evaluating this guy from 0 to 2. So 2 pi 1/4 times 2 to the 4th plus 2 squared minus 1/4 times 0 to the 4th plus 0 squared. Two to the 4th is 2 times 2 is 4, and then square that, that's 16. So 16 divided by 4 is 4, plus 2 squared is 4, and these are both 0. So we have 2 pi times 8 So we get 16 pi, cubic units. Right, so that's the shell method just for this region about the x-axis. And so next it says, find the volume of the solid generated when r is revolved about the line y equals -2. So we'll go ahead and take a look and see what does going off axis do to our graph here, do to our region, sorry. So we should be intersecting right there at 6, 2. And then we're going through, let me see. Yeah, 2 up that way. Right, and now we're going around here, the line y equals -2. And so we are going to end up reflecting about that line. I'll go ahead and make my region here. Right, so there's my region reflected about this line. Right, so go ahead and take a slice. Again, shell method, because otherwise we would have a really strange washer thing going on here. And so we'll see what this does to our cylinder other than make it very difficult to draw. Start from the bottom. There, that was better. All right. So again, what is our y starting at here, and then where are we ending up? We have to be very careful here because our slices will still stop right here at 0. Or sorry, start at 0 and still stop up here at 2. So our limits of integration are still 0 to 2. You have to think about what is kind of the lowest slice versus what is the highest slice. We shouldn't be slicing in here. There's nothing to slice. Okay, so now we've got this random slice, and we'll go ahead and look at this rectangle and see what are the properties of this rectangle. This little space in here is y, but that's now not the radius. The radius should be this all the way up. So this little space in here is y, but this space here is how much? It's the distance between this line and the axis, which is 2. So that's our radius, is actually going to be 2 plus y. Right? That also then will affect, let's see, what is our height here? Well, we're still going to have, let's see, 2 plus y squared. It doesn't affect the height. Wherever our y is, the only thing that's affected is kind of how far are we out from that middle point. That doesn't affect the height at all. So that's another cool thing, good thing, that we see about the shell method, is that the only thing that's affected when we start changing up the line that we were revolving about is the radius. It doesn't change the height. So back when we were working with the disc and washer method, it kind of changed everything because it changed the inside radius and the outside radius. Here, if we pick a different line to rotate about, it only changes the height of our cylinder. Sorry, the radius of our cylinder, not the height. Right? So that's another cool thing about the shell method. I'll go ahead and start to solve this now. Put the dy at the end. By the way, having the dy at the end, I know is going to be easy to forget, but I am going to have to grade on correctness with that. I have to make sure that you have that, so you will lose points if you're missing that dy. So be careful about that kind of thing. And so on the inside, we have 2 plus y and 2 plus y squared. So we'll go ahead and multiply these guys together. So first, outside, let's do inside first. Outside, last. Now it's in ascending order. We got 2 pi, and we'll go ahead and just run through power rule. Increase the power by 1, increase the power by 1, divide by the new power, increase the power by 1, divide by the new power, increase the power by 1, divide by the new power. So we got 2 pi times, we'll go ahead and open up the brackets again. 4 times 2 plus 2 squared plus 2/3 times 2 to the third plus 1/4 times 2 to the fourth minus, and then we've got a bunch of zeros, but we want to make sure that we don't take this for granted here. We do want to make sure that everything actually does turn into 0. Okay, and it does. 0, 0, 0, 0, that's all 0. So 2 pi 8 plus 4 plus 2 times 8, sorry, 2 to the third is 8 times 2 is 16 over 3. Plus, and we've already seen what this is. This should be 4 from over here. So we've got 2 pi 8 plus 4 plus 4, that's 16, plus 16/3. And we want to turn this into a single fraction here. So 16 times 3, it's going to get 48. All right, so 2 pi times 48 plus 16, we've got 464. Then we'll multiply by 2 pi, so we get 128 pi over 3. And then cubic units, right? So that's going to be our solution for if we move that radius out. As it says here in the restoring order section, this is talking about restoring the order in your mind. So it says, after working with slices, discs, washers, and shells, how do we decide what we're doing? First, sketch the graphs of the equations, right? Sketch your base. Determine the slice. By determine the slice, it says make your line either horizontal or vertical, whichever way is more consistent, right? If we did a vertical slice here, there would be a consistency issue. If we keep making vertical slices, all of a sudden we run into an issue here. So determine your slice, whatever way is most consistent. This will tell you the variable of integration. So if you are making vertical slices, like back up here, vertical slices always mean x. You can think of it back in the first learning about integration. If you're doing just a volume under a curve, you do vertical rectangles, right? That means you're doing x. If you've got horizontal slices, like we have in these two cases, it means your variable of integration is y. So that's what number 2 says. Number 3, compare your slice to the axis of revolution. Right, so if you've got a horizontal slice and you're going to be revolving things about the horizontal axis, then you're talking about, as it says here, the slice for shells is parallel to the axis of revolution. So if you're doing horizontal, you've got a horizontal revolution, it means you're doing a shell. Back in our disc washer method, right, if we were looking at something like this, and we were going to be taking a vertical slice, and we were going to be revolving this way, you can see that it's perpendicular to the axis we're revolving about. If it's perpendicular, that means disc washer. Right, so that's kind of a quick way to figure out which one's which. Are you using X or Y? Are you using disc or shell? Then you integrate. Right, so that's going to be the end of then 6.4. And so remember that that means that 6.3 and 6.4 are both going to be due. And also remember that if you have any questions, don't hesitate to email me or come find me in office hours.